the introduction, but hopefully it will also bring some new aspects. I'll try to keep it at maximum 10 minutes so that I give the chance to Cosmin to spend the time where it matters the most on presenting to you the new features in Domibus 5.0, which is the topic of the webinar. So we could move to the first slide. The Digital Europe building blocks is the family of building blocks that eDelivery is part of. And very briefly, what are we doing in the building blocks space? We are looking at defining specifications, profiles of standards, building sample implementations, providing ancillary services. So in a word, we want to prepare a lot of puzzle pieces that then you in your projects can use in different shapes, in different forms, to create the wider architecture that you need to obtain without having to, of course, reinvent the same things over and over. We do that by promoting generic standards, open standards that can be applied in essentially any sector. So we take great care to make sure that what we do is completely sector agnostic. And the main objective we are targeting is to promote interoperability inter-projects, inter-borders, inter-sectors. So we want to move the digital administration and the use and the interactions with the private sector into an area where not every project defines its own variations or flavor of more or less similar standards. So that's what we try to achieve. And how do you use a building block? Well, either you reuse existing software. It can be the sample software that we are creating in the building block itself. It can be any of tens of market products that have been created by private vendors, by open source projects to implement the same specifications. Or you could also build your own implementation of the specifications we have. But that usually is not really necessary. So it has to be a very special case where you may want to build something from scratch. There are a lot of products out there, and I think it's ideal that you find one that suits your particular configuration and use that. So we can move to the next slide. And this finally shows you a little bit of the perspective that we see looking back from 2014 all the way to today, and this shows us quite some impressive numbers of projects, of sectors, of member states that have started using the building blocks. And from essentially zero, we are now today at a point where we have a lot of projects that are built around the building blocks, and a lot of projects that are in the pipeline, which have already selected one or multiple building blocks to assist their architecture. So we see a lot of interest, a lot of growth, and I think we will move together with many of the other building blocks in this new era, if I can call it like that, of data spaces that are being prepared all over the public administration at the moment, and equally in the private sector. And we are very keen to engage with those projects and bring building blocks to support them. So we can move to the next slide. Now, to speak a bit more concretely about eDelivery, the building block we are here to discuss is about exchanging data and documents securely and reliably over an open network. Of course, it doesn't mean that you cannot use it in a private network, but the goal is, of course, to secure the communication over an open, insecure network. And we look at aspects such as interoperability, which is really about making sure that everybody can create projects that from their initial stage can interact with other projects because they are using the same specifications. We are looking at scalability and performance, especially of eDelivery networks. So we want to not only discuss performance at the product level, which is something you will hear quite a bit about later today, but I would say even more so at the network level, where it's important that you can start a project in a small way and then grow it to the size it needs to take for it to stay meaningful. We have security and accountability as one of our driving forces as well, because we are first and foremost about exchanging data securely. So we have to look into that very closely and on a constant basis, to monitor vulnerabilities, to patch them, to look into our specifications. We are currently engaged with an exercise to modernize the cryptography algorithms that we are using, just to give you an example. And so on and so forth. So security is at the core of what we do, and accountability is part of providing legal assurance that exchange of messages is not just assumed to be successful, but in fact there is a way that somebody who sent a message can prove that this message has been confirmed as received by the other side. This is usually not necessary, but of course in legal disputes this can become an issue. And finally, we want to stay, well, we are and we want to stay vendor and platform agnostic, and this is by design. So we don't want to create the building block around the product. We want to create it around the specification in such a way that even if one product comes and the next one, or one product goes, the next one comes, the projects are minimally impacted, because normally the products are able to exchange messages using exactly the same technical specifications. We can move on. How does eDelivery as a principle work? So you have a sender that wants to send a message to a recipient, and the way to do that is by not directly implementing a common standard, but instead by using an intermediary layer of what we call access points that themselves implement a specific flavor of or a specific incarnation, I would say, not flavor, of the AS4 profile, which is of the AS4 standard, which is what we mandate in eDelivery exchanges. So you have a sender interacting with its local access point, with the access point that is deployed in its own network, or very close to it in any case, in a logical sense at least. And integrating with this access point through proprietary interface, which is not mandated by delivery. So depending on the product you select, each product will have its own approach to how backends can integrate with it. So this model is replicated actually on both sides. The sender does this, the recipient does the same, and in between the access points, we have the standardization that comes into play. How does the message travel? It's submitted by the sender to its local access point. Then this access point will do a series of processes, including validation, signature, encryption, send it to its counterpart access points on the other side, where a reverse process takes place, and some additional steps to validate the signature, to create and send back a digitally signed acknowledgement of receipt if the message proves to be correct, proves to not have been compromised in traffic, and so on. And finally, the receiving access point will store the message it received so that its recipient can download it. And this is, of course, the final step which completes the transaction, where the recipient eventually retrieves the message from its own access point. We can then see in the next slide, and I will insist a little bit on the terminology here, because Cosmin will be referring to these names quite often throughout his presentation. So we have the so-called four-corner model. Again, those of you who have been watching our webinars over the years are certainly familiar with this, but for those of you who are new, I spend 1 minute to explain this model. So it is essentially what I showed in the previous slide, but here you have more of an architectural view of the same principle. And we call the access points the corners 2 and 3, the inner corners, because where does this naming come from? If you have a two-corner model, it means that the backends speak to each other using web interface, web services, or some other interface that they agree on. Possibly queues, who knows? It depends from a situation to the next. But of course, this makes the interfacing usually custom to the specific business case. And then by introducing these two additional corners, the corners 2 and 3, as we label them, the inner corners, we transfer the interoperability concern to the corners labeled 2 and 3. And then between corner 1 and corner 2 on the one hand, and corner 4 and corner 3 on the other hand, the API no longer needs to be standardized. And then, of course, the message flow is essentially the same one I explained on the previous slide. But what is important to keep in mind from this one is really the names we give to these four parts. So when we will speak about Domibus later on, usually Domibus will be used either as corner 2 or as corner 3, or in some cases as both. It depends on the specific case. Whereas corners 1 and 4 will typically be IT systems that are not defined by eDelivery, that are not specific in any way to eDelivery, which are your IT systems that will be interacting with each other through an eDelivery intermediary of these two access points. So we can move on to the next slide. Here you see the services we offer in addition to the software that we developed to implement the technical specifications. We also have some operations related services, whether they have to do with provision of certificates, whether it has to do with providing so-called service metadata locator service, which is relevant in case you want to use eDelivery in a bigger network where you want to use dynamic discovery to discover the access points you need to contact. Let's say you don't know them ahead of time, you need to discover them at runtime, and this happens through a set of components called SMP SML, and we have a service for one of these components which we offer. We have a connectivity testing service that helps you validate an installation of an eDelivery access point was done in a correct way and can exchange messages at the basic level with our test service. Similarly, we have a conformance testing service. If you develop products that want to implement our specifications and you want to ensure that these products have implemented the specs in a correct and complete way, then this service is what can help you obtain a certification that the product indeed has achieved this objective. And several others. So I will not go through each and every one of them that you see on the slide. They will be available in the presentation slides after the webinar. But my point here is that we have not just the software, the naked software and the specifications, but also a lot of services, and yourselves, you are benefiting from one of our community building, let's say, services, because we want to use these webinars to get you in a room with us, to inform you about what we're doing, and to maybe give you an easier look inside of some of the new things that are coming with eDelivery. So we can move on to the next slide, where we show, indeed, I've been mentioning this a couple of times already. We have the conformance testing service that allows vendors to pass a series of tests and have their products validated as conformant to the eDelivery specifications. And this is a screenshot of the most recent list that we have of such solutions on our page, among which, of course, you will also see Domibus, the one that we are building, that will be presented in the remainder of the webinar today. But of course, alongside Domibus, you see plenty of other ones to choose from. So we can now move to the topic of the webinar itself, where Cosmin will go in depth on the 6 bullet points that you see here, that essentially represent a screenshot of what is new in Domibus 5.0 compared to the previous version. I will let Cosmin delve into this at length, so I just wanted to give you a preview for now, that we are talking about major performance improvements, about support for e-archiving, for new modes of operation of the web service plugin, and so on and so forth. Again, Cosmin will go into each and every one of these in depth. And the final point I wanted to touch upon is on the next slide, the list of application servers, database servers, and Java 8 support that Domibus 5.0 comes with or provides support with. I will not read this out, but I just wanted to say that we may not be aligned with the very latest versions of every one of these, which is not because we wouldn't like to, but because, of course, as every project, we need to respect certain constraints that come from our environment in the European Commission. And this is, let's say, the compromise we have to make. But rest assured, we are following, even if maybe a bit at a slower pace than you would like us to, the fact that Java has moved beyond Java 8 already a long time ago, the fact that we have newer versions of WebLogic and so on. So in 5.0, we are aligned with the set of servers and Java versions that you see on the slides. And we are already preparing Domibus 5.1 and soon thereafter 6.0, which will further upgrade the support to the current generation of application servers, database servers, and Java, which I know that a lot of you are interested. So with this, I want to hand over to Cosmin to take you through the features.
Thank you, Bogdan. Hello, everybody, and welcome to this presentation. So in this presentation, I will walk you through the Domibus 5.0 features and improvements. The main topics I'll talk about today are improved overall performance. We'll talk each topic. I will talk about each topic into detail later on. But today, just we have to mention the high overview topics. So the next topic would be the Domibus administration console improvements. Then I will talk about the new web service plugin we have added in 5.0. Next topic would be the possibility to use an external agent to archive the messages in Domibus. Then we'll talk about validation of incoming user messages in a central point using a validation extension. Then how to send payloads using references in using the GMS plugin. And finally, we'll talk about the possibility to offload the HTTPS traffic to an external component. Let's talk about the improved overall performance in 5.0. We have done a lot of, we have put a lot of work into making the performance achieve a very good performance in 5.0. We had performed internal tests with a cluster of four Domibus instances, and the performance we achieved in 4.2 was 300 messages per second, so sent and received, 150 messages per second sent and 150 received. We have done a similar test with after we have implemented the performance improvements in 5.0, and we have achieved a performance of 1,500 messages per second. So five times improvement comparing with 4.2. These 1,500 messages per second are 500 messages received and 1,000 messages sent. What we did to achieve such a great performance, one of the main aspects we have improved was to refactor the database to allow partitioning and improve the overall performance. But before going into the details of this topic, I would like to quickly explain what is database partitioning. So database partitioning allows tables, indexes, and index organized tables to be subdivided into smaller pieces, which enables this database object to be managed and accessed at a finer level of granularity. So we have enabled Domibus to be configured on Oracle database with partitions. MySQL probably will follow in a future release. And for this, so for enabling partitions, we have modified the primary key format to embed a certain metadata. So in 4.2, the primary key was just a simple number. It didn't contain any special metadata. But in 5.0, we have modified the primary key so that it contains the date. So the primary, the first two digits are expressing the year. Then the next two digits are expressing the month, then the date and the hour. So we have a granularity of 2 hours actually here. Here we have an example of a primary key. So this means that this message has been exchanged at 5th of October 22 at 7 a.m. And this is the rest of the 10 digits, which is just an incremental number. So to enable the database partitioning by primary key, we had to link all the database tables in which the messages are stored using foreign keys. In 4.2.2, this was not the case, and therefore we had to do this work. What are the benefits of database partitioning? First of all, it enables faster search in the application, so at runtime, but also in the Domibus administration console by taking advantage of this primary key format and also, of course, of the partitions. Due to this performance improvement, we managed to remove the old UI replication mechanism, which is actually adding a little bit of overhead to replicate the data. Another benefit of database partitioning was to enable Domibus to delete messages in a faster way. So the retention mechanism is able to delete thousands of messages in almost instantaneously using partitions. So the partition is deleted very fast. Another benefit of the database partitioning is that you don't experience degradations, almost zero degradation of performance over time, even when data is accumulating millions of messages. In order to further improve the response time in the Domibus administration console, we have also added by default of filtering. So we have here a filtering that was added, and actually this can be adapted in Domibus properties. By default, it's 24 hours. So let me show you live how it is. So we have here the filtering. You can also filter by, if you have really a lot of messages exchanged, you can filter by show the messages which was exchanged during the last 30 minutes, 1 hour, and so on. Brief mention of other technical improvements. These are really too technical to be discussed more into detail, but I will mention them briefly. So in Domibus 5.0, we have removed the e-sig transactions, which were used between database and GMS. We did extensive refactoring to minimize the time spent in transactions. So we have removed some such calls which are actually, let's say, dealing with the file system, which were not meant to be in a transaction. We have also enabled second level cache for Hibernate, which is mainly used for static data like dictionary data, for instance, values for service, action, some properties, and so on. We have adapted the caching for database sequence. So normally when you write into the database, you need to obtain a value from the sequence. This time we obtain by default 50 values, and this enables us to write 50 times into the database without getting the next sequence from the database. Lastly, we have enabled the possibility to enable asynchronous logging so that the application is not waiting for the logs to be written on the disk. Next feature where we have applied the performance improvement is the pull mechanism. But before going into the details, I would like to give you a brief overview how pooling is working. So in a classical scenario, in a push scenario, we have the corner 2 here, which is sending a message directly to corner 3. This is a push mechanism. In a pull mechanism, The access point which holds the user message is this one, is C3, it's not C2. And C2 sends a pull message to the C3, which responds with the user message, and therefore it reaches corner 2. This is how pulling is working. Pulling is used when, for instance, one of the corners, in this case corner 2, cannot be, it cannot open a traffic to the internet, so we must initiate the connection. So what was the issue with the pull performance? In 4.2, the locking mechanism, which was used at the C3 side for pulling the mechanism, had a really bad performance due to unoptimized database locking. So why is locking needed actually in this case? Because C2 can send parallel requests to C3, C3 must protect to send the same message twice to C2. So it cannot send the same message multiple times. So in order to avoid this, C3 needs to use locking and skip and let's say protect that message which is sent to C2. In 5.0, we have improved the locking mechanism, which is giving a better performance when using pull. A nice feature we have added in 5.0 is the possibility to manage the TLS trusters, the certificates that are used for HTTPS communication. So the ones that are one-way TLS from C2 to C3. In 4.2, this was not possible. It was possible outside of the administration console by just updating a configuration file, XML file. It was not so user-friendly. Actually, I want to show you a quick demo of this. So the new TLS TLS management page, you can have it under the Trustor page TLS. As you can see here, I don't have any certificates, but I will show you how to upload certificates. I will fill in the password for the Trustor. So as you can see, the certificates were successfully uploaded, and so this is the initial provisioning of the certificates, but you can also manage them one by one. So for instance, I don't need this certificate anymore. I can just remove it. Or if I just want to add one certificate, I can just do that. I just need to fill in the alias under this certificate will be added. And then you can see that the TLS trustor has been successfully uploaded. So the next feature I want to show you is the possibility to visualize the non-repudiation of origin and receipt in the administration console. But first, I would like to explain briefly what is non-repudiation of origin and receipt. So when C2 sends a message to C3, one of the parties can claim that they did not send or receive the message. So in this case, by using the non-repudiation of origin and receipt, both parties are the sender can claim that it has successfully sent a message to the receiver, and the receiver can claim that the sender has sent him a message. Let's see how this is working. So I have here in my Domibus instance, I have some messages which were received. So I will go here to this envelope. Now download the non-repudiation information. So I will just go here and I will open it. As As you can see here, it contains the full sub envelope of which contains the messaging information, the S4 messaging information, plus the security part, which contains the signature element. And this signature element has these reference elements, which actually contain, so these digest values, they represent the signature of the messaging element, the body element, and of the each payload that has been transmitted. So with this information and the original payload, you can claim that one of the parties has sent or received a message. Okay, then let's talk about a really interesting feature in 5.0. This is very useful if you operate Domibus in multi-tenancy mode. Just a quick overview: what is multi-tenancy? So normally, when you operate in single tenancy, you can serve only one party. So one party has a key store, a trust store, so a certificate, P mode configuration, and properties of property file of the Domibus instance. But when you operate in multi-tenancy mode, you can reuse the same Domibus instance, but you can configure multiple tenants on this instance. And each tenant has its own set of configuration. So the data for each tenant is stored in a dedicated database schema. So the data segregation is done at a database level, database schema level. The tenant has its own key store, its own trust store, P mode file, and properties file. So this is multi-tenancy. In 4.2, when you had to add a new tenant, a new domain in Domibus, you had to stop the server and then restart it. And this is not good for high availability. So what we have done in 5.0, we have enabled you to add a domain and remove a domain in a live running application without stopping the server. I will show you live how this is done. So we have here a new page where you can manage the domains. As you can see here, I have two domains. I have the default domain and I have domain one. So I will show you how to add a new domain. So here is my Domibus configuration directory, where I have the configuration for the default domain and for domain one. And I want to add a new domain. I've already prepared the configuration for this for the new domain, domain two. So you see it has the key store, the TLS trust store, the trust store for Domibus, the properties file, and the logback file. So let's add this. So I'll just put it under the domains directory where you have the configuration for all the domains. I'll go to the Domibus administration console. And I will refresh the page. As you can see, Domibus already detected that you have a new domain added, but it's not yet enabled. It's not yet active. So I will activate it now. Once I activate it, it will enter into force. So you can already use it. Let's check this. For instance, I'll go to the messages page. And as you can see, I have my new domain here. Domain 2 is already added. If you don't need this domain anymore, go to the domain 2 page and you disable the domain. And normally this domain is disabled. So this is how you manage domains at runtime. Really a nice cool feature. In 5.0, we have added a new web service plugin, which actually it contains so in 5.0 we have the old plugin, the old AWS plugin, and the new WS plugin. The old WS plugin has been retained to avoid breaking the backward compatibility with existing users who have integrated with Domibus using the old plugin. But the old plugin will be deprecated, has been deprecated, and it will be removed in the one of the next Domibus major versions. And we strongly encourage you to plan the migration to the new WS plugin, to avoid disruptions. So what is the endpoint of the old plugin? As you know, Domibus Services backend. The new plugin is Domibus Services WS plugin. We have removed the old deprecated Ecotex namespace, and you have the new namespace here. But also what is new is that we have added push functionality. And I will show you in the next slide what is push functionality. But before showing you the push functionality, a quick reminder how pull is working. So we have corner 1 here. We have the original sender submits a message to its own corner 2, who sends a message to corner 3, and then the message is arriving in the WS plugin. So this corner 4, he wants to consume the received message. How this is done in pull mode. So the backend polls constantly for pending messages and asks the plugin, do you have messages for me? Receive messages. And once the backend plugin, the backend gets the list of message IDs which were received, it will, for each message ID, it will call the retrieve message operation and it will download the message. So this is how pull is working. When pull mechanism is useful, this is useful where the backend cannot implement a SOAP web service, which is mandatory when you use push, or when the backend cannot open incoming HTTP traffic due to security policies, for instance. So the flow, we have already seen it in the previous slide. And as you know, you can also call the get status operation in pull mode to check the status of a message. Now let's see how push mode is working. So we have the same original sender corner 1, submits a message to corner 2, message arrives in corner 3, but this time the message arrives to the WS plugin, which pushes the message to the backend. So the S4 metadata plus the payloads are pushed to the backend, and backend does not poll the pending messages anymore. So this is more efficient. It consumes less resources. In the same manner, other events related to the lifecycle of the messages are pushed from the WS plugin to the backend. So what are the requirements for push mode? The backend must implement, of course, a SOAP web service WSDL file, which we provide to you in the distribution, so that the WS plugin can call you for push notifications. So here we have the full list of the push notifications that the WS plugin can use to notify the backend. So when a message is sent from C2 to C3, you have the send success notification. Similarly, when the message fails to be sent, you have the send failure. Submit message we have seen previously, that is used to push the message from the WS plugin to the backend. You have the receive success notification when C3 is receiving a message from C2. You have the receive failure when C3 from various reasons cannot accept a message. You have message status change, which is used when the status of the user message changes. For instance, you have failures and the message status changes from sending queue to waiting for retry. You know when this happens using this new notification. Of course, you get notified also for send failures and success and so on. So very, very useful. And you can also be notified when the retention mechanism kicks in and starts to delete messages which are expired. So we have the delete event, which is used when one user message is deleted, and you have the delete batch event, which is used to inform you when a batch of messages is deleted. A nice improvement we have added in the new AWS plugin is the enhancement of the list pending messages operation, which now supports filtering the messages. In 4.2, as you remember, this method was just returning all the messages that were received. You could not filter them. In 5.0, you can filter based on the message ID. So let's suppose that you already know the message ID that you want to consume. You can do that. When you have a series of messages that are exchanged and are related between each other and they share the same conversation ID, you can use the conversation ID to filter those messages. Ref to message ID is very useful when you have a two-way communication. So you have a request, which is the user message, which is sent from C2 to C3, and then C3 responds with another user message following the initial request. So the response, the reply back contains ref to message ID to the original message, and then you can use this. You can use this to find the reply to your initial message. Then you can also filter by the party ID, so the party ID of the C2 access points. And also other useful filters are original sender, final recipient, and you can also filter during messages which were exchanged during a specific interval, so from date to date. Let me show you how this is working in practice. So I have here the SOPI project for the new web service plugin, and I want to see what are the messages that are pending for me to be consumed. So as you can see, I have a couple of messages. So I don't use any filtering for the moment. But if I want, say I want to filter only the messages which have the final recipient with this value. So you can see this is working fine and filters me these messages. Of course, you can also use from date and receive from and receive to. So you can filter also these messages based on a date. The full filters, you can find them when you open your new request. My SOPI is a little bit slow. So you have here the full filters. Okay, next feature, which is really interesting, is about the archiving. So when you have a Domibus instance, which is in production since quite some time, and you exchange a lot of messages, data is accumulating into the database, and at some point you end up with a lot of data. And possibly you don't need all the messages, old messages in the database. You want to, let's say, get rid of them, but you don't want to lose the information. So in this case, you can use archiving, which is a way to extract the data from Domibus and delete and delete, and then you can delete the messages which are old. So let me explain you how this is working. So you have a Domibus instance here, and you have an archiving agent, and these two are integrated using REST API. You will see later on the interface that are used to communicate between them. So how is working? Domibus exports messages in batches on a share file system, so one batch at a time. Then it notifies using a REST API the archiving agent, which will get a batch from the share file system. It will archive it, And upon successful archival, it will notify Domibus using REST API that it has successfully archived the batch. And then Domibus is based on the retention configuration is capable now of deleting these messages that were archived successfully. Even if the retention mechanism is met, so let's say a message is expired according to the retention mechanism, if this message is not archived, it will not be deleted. So this is the behavior when archiving is activated. If archiving is not activated, it will behave like before. It will delete the message once the retention mechanism kicks in and the message is expired. So this is the interface, the REST API that is documented using OpenAPI, and this is published on our website. As you can see, you have plenty of resources to use to integrate your e-archiving client. Same is for the e-archiving client side, where you have to implement specific OpenAPI which is documented on our website. So as said previously, Domibus only exports the message in a share file system, but not all of them. Only the one that in the final state. So final state meaning received, deleted, downloaded, or acknowledged. Before exporting the payloads and the messages on the share file system, they are decompressed. You know, some payloads are compressed, especially the ones that are to be sent. So all the messages are exported in batches, not one at a time, and each batch has the structure of a argzip format. Argzip is a format which is used in the e-archiving industry. It's a standard. So this is the structure of a batch. You have the batch directory, which contains a met.xml file, which is also a standard from the e-archiving industry. I'll show you later on what are the contents of this met file. And this batch directory contains all the messages. So one message at a time. Each message has the SOAP envelope and each payload. The batch directory contains also a file called batch.json. It contains some metadata, which I will explain you later on. So what is the structure of this met file? I will briefly mention it because it's kind of complex. It's not the point of this meeting. So the main point of this met file is to list all the files that were exported and with their checksum. You see the checksum of the file and the file that was exported. Using the checksum, you can check that there are no files which are corrupted. And also we have the structure of the batch.json file, which contains the version ID, so the version which is of the data which is exported. You have the batch ID, you have the request type, you have the status, failed or succeeded. If it's failed, then you have some errors information, the timestamp when the batch has been exported, the start and end date of the messages that are exported in this batch, and you have the list of message IDs. Then I will show you a quick demo how the e-archiving is working. We'll delete these messages that I have for the moment. So the retention mechanism will quickly kick in. In the meantime, I can show you the configuration of the archiving mechanism. So we have here the configuration. So I have activated the archiving. I have configured the archiving to export messages in this location. and I kind of aggressively put the cron jobs to kick in so that we don't have to wait a lot of time. And also I've configured the archiving agent, which is already started on my machine under this URL. As you can see, the messages were deleted by the retention mechanism. So check that we don't have any patches. Very good. So now I will send some messages. So my instance here is acting as a blue. As you are familiar, we are using blue and red terms for designating C2 and C3. So I have the blue instance here, and I'm having another red instance on my machine, which is used now to send messages to my instance, just to show how archiving is working. Okay, I think it's enough. As you can see here, I have some messages which are waiting to be archived. So the archive column, as you can see, this is empty for the moment. I have to refresh a little bit so that we know when the messages are archived. So now the archiving cron job is working and checking if there are messages that are waiting to be archived. As you can see, these messages were archived, and the batch containing those messages has been created with the structure that I explained before. So the sub envelope and the message attachment. Now that the messages are archived, they will be deleted soon. So we have here the retention downloaded to 0, meaning that you can see the messages were already deleted. So this is a way how to archive messages from Domibus without losing the data. Another feature we have implemented in 5.0 was the possibility to centrally validate the incoming user messages before they are delivered to the plugin. And this is done using a validation extension. Validation extension is actually a module, a new Domibus module, which implements a specific API, which is documented. So we have created a validation extension cookbook. You can find it on our website, which explains how to implement the validation extension. Validation extension can be deployed similarly like you deploy a plugin, a Domibus plugin. Just copy it into the extensions lib directory. So a couple of scenarios where you can use the validation extension. You can, for instance, plug in an antivirus into the extension, and then you can scan the incoming messages using the antivirus. Or you can implement auditing, central auditing, or you can centrally enforce the message payload validation. You want, for instance, to ensure that incoming user messages contain a payload, which is an XML file, and respects a certain structure, for instance. But yeah, depending on your business case, the possibilities are endless. So the validation extension, how it's working. You have the four-corner model. Again, C1 corner 1 submits a message to corner 2, which sends a message to corner 3. The message is received. But this time, before notifying the plugin, the validation extension kicks in. It validates the message, and if the message validation passes, the Domibus will notify the Domibus plugins. If the validation extension the validation does not pass in the extension, then synchronously a signal with an error message will be sent to C2. A nice feature we have implemented in 5.0 is the possibility to offload the HTTPS traffic to a component, infrastructure component. As you know, by default, when you have a HTTPS communication between C2 and C3, the HTTPS communication, the connection is initiated in Domibus as a client, and the TLS trustor is used. When you want to offload the HTTPS traffic, then you use an external component like a proxy, a foro proxy. And the communication is, the HTTPS communication is not initiated by Domibus, but is sent in HTTP to the proxy. And then the proxy initiates the HTTPS communication. This kind of proxy is very useful when you have an organization which centrally manages the HTTPS traffic, which manages the HTTPS certificates, for instance. They have plenty of applications and they want to enforce this using a central component. We have improved also the JMS plugin, and then and now in 5.0 you can use the JMS plugin to send payloads by reference. So normally in a normal scenario, typical scenario, the backend sends a JMS message to the broker, and the payload is contained in the JMS message. The payload bytes are in the JMS message. So how this is working, it goes to the broker, then the JMS plugin consumes the JMS message from the broker. It submits the message to Domibus C2, which sends it to C3. So this is perfectly fine if you have small payloads, but once you have payloads which are bigger, let's say 10 megabytes, more than 10 megabytes, maybe even more, then it starts to be problematic because JMS brokers are not meant to be used with large files. So how you deal with the situation? You can enable sending the payload as references. So the backend puts the payload on a share file system and sends a message to the JMS broker with the payload reference, so the file location. Then the JMS plugin consumes the message like before, and then gets the payload reference from the message and fetches the payload from the file system in this case. Then the JMS plugin again submits the message to C2, and which sends the message to C3. So this is a nice way to deal with large files and using the JMS plugin.